Hello and welcome back. My name is Rohit, and in this video we are going to talk about lists. Right? In our previous video, we saw, we learned about tuples, and in this video, we'll basically have a look at lists. So, once again, what is a list? A list is an ordered sequence of data, just like a tuple. The difference between a tuple, list, or integer, float, and string is that, integer, float, and string data types can only hold one value, right? You can assign only one value, but tuples and lists are basically ordered sequence of, data. So you can have multiple values in just one variable, right? So how do we define a list? So what we can go do is basically we can have create a variable, and we can open a square bracket and have our elements defined in that, separated by commas, right? So this is how we define a list, right? So I can verify this using the type function. It gives me a list. So if you remember, in tuple that we created in our previous video, we basically defined it by opening a parenthesis, right? And then having our, defining the elements of that particular tuple separated by comma, right? So this is a tuple, and what we created in our first line, this one is a list. So basically, definition wise, you won't find much difference. The only difference is that, lists are defined using these square brackets, and tuples, if you define a tuple, if you define an ordered list or an ordered sequence of data using parentheses, there'll be a tuple. And if you define that ordered sequence of data using a square bracket, this is going to be your list, right? So what is the difference between tuples and list? Tuples, or tuples, as other people may call it, as we saw that they do not allow us to modify anything. We cannot modify any of those elements. We can't add new elements. We cannot remove elements. We cannot add two tuples together, right? So there are certain limitations. And let me show you. If I check out the methods of tuples, we have seen that we only have two: index and count. We already saw in our previous video what those are. And if you see, I'm just going to show you, we won't discuss this right now, but see, append, count, extend, index, insert, pop, remove, reverse, sort. There are so many different functions that lists can do, right? So lists are more dynamic than tuples. Actually, tuples are not dynamic. Tuples are totally static, but lists are dynamic. Now, why would you want to use tuples, right? You might be thinking, right? So tuples is a good way to store read-only data that you may not need to modify in your program, right? So that would be a very good use for tuples. Tuples are generally considered slightly faster than lists. If you have so much data to store, you can basically use tuple. If you don't expect that data to change, you can use tuples because they'll allow you, you might have some performance benefits. At least that's what I haven't been, I have not practically seen any difference because I don't deal with that much data. But if it's a need that if you have to deal with a lot of data, a lot of ordered list of data that doesn't change frequently or doesn't change at all, you could use tuples. That'll give you a tad bit faster performance, right? So now I want to show you one more function that we really actually missed in our previous video. So the function is length function. So it is len. Now, the type function tells you the type of that particular data type. The length function gives you the length of the list or the tuple. So if I pass in list, lis, how many elements are there in the list, right? There are 6 elements. Cool. 1, 2, 3, 4, 5, 6. There are 6 elements. Similarly, we can use this function on tuples as well. And we get the length of the tuple. Now we cannot use this function on integers, floats, because they basically an integer value does not have a length. That's basically not a it's not a string, it's not a list. So going further now, lists can also have dynamic data types, so it's not mandatory for you to have list of all integers. You can basically have 1, 2, and then you can have a a string, the IP school, right? And you can have a float value, right? And you can have an even bigger string. For example, we can have Python or network automation in Python, right? We can have this string as well. So this is, the tuples and lists basically can be defined in similar ways. You can have different data types in that particular list or a tuple. Now, similarly, when we saw in tuples, how are lists organized? Pretty much similar, right? So if now you have to understand the element 1, the integer value 1 is at index 0, integer value 2 is at index 1, the IP school string is at index 3, this particular float value 3.2 is at index 4. Oh, I'm sorry, is at IP school is at index 2, 3.2 float value is at index 3, and network automation on Python, this large bigger string is at position 4, right? So those are the position values, those are the indexes. It is exactly similar to tuples and similar to strings as well, right? Strings are organized the same way, tuples are organized the same way, lists are organized the same way, right? In a string, let me repeat that. In a string, for example, the string is the IP school. It starts with T starts with 0, H is position 1, E is position 2, I is position 3, P is position 4, S is 5, C is 6, H is 7, O is 8, the another O is 9, and L is 10, right? So similar way, lists are organized where the element has an index, right? Not the character. In lists, in strings, the character is at an index, right? T character is at index 0. H character is at index 1. Now, in this list, the element is at index 0, right? So when you look at the list, right, the index will fetch you the element, right? The index will fetch you that value, right? So let's practically do that. Now, let us extract network automation in Python. Which index is it? It's 4, right? Or is it? It's 4, right? 1 is at 0, 2 is at 1, the IP school is at 2, 3.2 is at 3 position, and network automation in Python string is at 4 position, right? We get that. Now, this index 4, it basically refers to this string. We can format it further. We saw this in tuples as well, but we can we can filter this further. We can extract from this large string. What we basically need to do, we will again reference to an index value within the string, right? What we have done right now, this portion will reference the string, and now we can reference a value within the string and a character within the string. So what we do, if I reference position 0, that is what? That is N, right? Similarly, position 2 is what? E. Oh, it's 2. E is position 1 and T is position 2, right? So T is position. Now again, when we learn strings, we saw this. You can basically have a range of you can specify a range of values. So what you basically can do is uh, you can specify from 0 to, let us extract network, right? So n is 0 and 1 2 3 4 5 and 6. K is at position 6. So should we type 6? No. Why? Because now we will extract the string not including 6. We'll extract it up to 6 but not including 6. 6 is the index, 6 is K. We will not include K, right? So you remember this from my string video. So we have to specify 7. Why? Because it will go, the 7 is this blank space, right? Index 7 is this blank space. It will go up to 7 but not include it. It won't include it, right? So now we saw how we could refer an element, a string element in that particular list, and then extract, further extract from that string, right? So similarly we can do that. Now again, there are certain functions that I would like to show. The first one is we've seen this function before. The function is index, right? We have seen this function with tuples. Now index will tell you the position of that particular value, right? Position of that particular element. So now what we can do, we can basically check the position of 2. Now what is the position of 2? Position of 2 is 1, right? We can check the position of the string, the IP school. Oh, see the IP school. Oh, I did a mistake. See the IP, it has to be S. I typed a wrong character. Now it gives me an error. It throws me a value error. The IP ACHOL is not in the list, right? So that was a mistake. Let me do that again. Right? So you get that. Now let's jump to modifications. Tuples we could not modify, lists we can modify. So what we want to do is basically we can add an element to the list. So let's go through all those list functions. So let's print what is our list, and now let's go through all the functions. Append. What does append do? Append will basically add one element. See here, you get this list which which basically tells you append object to end. So it will basically add one value to the end of the list. So what we'll do, we'll basically let's add hello. Let's add this value and see what happens, right? Let me print my list again. See, hello is added to the end of the list. So that was the append function, right? Now let us see some more functions. We have count. Count will tell you the occurrence of that particular element. We have seen this function in tuples as well. One is occurring only one time right here, and it just gives us the count of that particular element. Now let us go through another. Extend. Now what does extend do? Extend basically it basically combines two different strings. It'll basically add it basically combines two different lists. It'll basically add one list at the end of another list. So what do we want to do? We basically will create another list 2, right? And let's have 1 2 and hello. Now you know that here we have defined one integer value, a string value because it's in quotes, and another string value, right? So we have two lists. We have one list lis and another list is lis2, right? So what we'll do basically, we'll extend both these lists. So what we'll do, list dot extend, and I will provide list2 as the argument to this function. Now let me print the list. The and what should we get? See, 1, 2, and hello were basically added at the end of this list, right? So they were extended. The lists were extended. The lists were combined, right? And what happened to list 2? Nothing. It's as it is. It's exactly the same. We just took that list and added it to the list function, the first list actually, right? So this extend function was invoked, was called on this particular list, right? So and this list too was provided as the argument, right? Now let's go through some of the functions. Index will again tell you the index of that particular value. So if we provide this float value, the index is 3, right? 1 is 0, 2 is 1, the IP school is 2, and 3.2 is 3, right? Also, let's go through some more functions. Insert can add or insert a value at a given index, right? So for example, I'll specify an index. So you can see from the help, index comma object, right? So first you need to specify an index. For example, I want to add to the beginning of this list. So what do? I'll specify 0. This is my index. So that means the beginning of the list. And let me add, another string, hello. I'm not creative with all this, but you will get the point, right? And let me print list. So you see we have added another hello list to the beginning, right? Let's try this one more time with my name, Rohit, and let's add this at position 4. Now, what exactly is position 4? So hello is position 1, then this is position hello is position 0, this is 1, 2, the IP school is 3, and 4 is this float value. 3.2 is at position 4. Now 3.2 will become position 5 and Rohit will be inserted at position 4. Let's print this and see, right? See, earlier 3.2 was at position 4, now Rohit is at position 4, and 3.2 has been, moved further. So you get this, right? Let's check out another function. Now we have pop. Pop will basically remove an item, but you have to specify an index, right? So for example, let us remove the first item. You see that we have removed this particular item. It also did what it basically did. It also returned that particular item that we removed. It'll give you that value back. Whatever we remove, it'll give you that value back. Now we have removed hello. Earlier it was in the list. Now it's not in the list. But notice what we had to do. We had to provide an index. So it is useful if you know the index of that particular, element. This function is useful. You could remove it based on the index value. What if you don't have an index value and you want to remove it using the value itself, not the index? You could use the remove function. The difference between pop is that pop uses an index to remove that particular value, and the remove function will basically use the value, not the index, as an argument. So let us do one thing. Let us remove hello. Now, if you see in this particular list, there are 2 hellos, right? One is at the end and one is somewhere in the middle, right? Here and here. Which will it remove? I bet it'll remove the first occurrence of this particular string, not all those hellos. Yeah. Now this hello is basically missing in this list. We have the hello that was in the last intact, right? So again, pop uses an index value. Remove function uses the value itself, not the index. Reverse, nothing, no rocket science behind this. It'll reverse the string. Reverse the list. Okay, the last element was hello. It reversed it, hello, and then the entire list is reversed. Now we did not see all those functions when we studied tuples. Why? Because tuples, you could not modify them, right? So reverse is modification, remove is modification, pop is modification, insert, extend, right? Append, all those functions are basically modifications. So you could not do any modifications on, tuples. So lists, you can do modifications, right? So we'll go through the last function, sort. And basically, sort is whether you want to sort it, how do you basically want to sort this particular list. Now, let's see what happens, right? So, let me print this list again. And now what you can see is that, see, earlier our list was basically unordered. It was ordered, but, it wasn't, in a proper alphabetically, it wasn't it wasn't ascending or descending order. The order wasn't correct, right? So what it basically does, it basically reorders the list in correct order, right? Now you can see that you have 1, right, and then you have 2, so it's basically ascending order, right? And if you can also notice, this 2 here is a string, right? First we have all the the integer values assigned in appropriate ascending order, and then we have this string 2. We have R. Now R here is a capital alphabet, right? And you can see that those small case, those strings which begin with smaller case are basically, are ordered differently than integers, and then the uppercase, those elements that begin with uppercase, those string elements that those begin with uppercase, right? So they're basically ordered separately, right? So those were all those all the functions of a list. And let's see, we don't have any other functions. We saw how we could append an item, right? Append will always add it to the end. Count will give us the count of the number of occurrences of any particular element. Extend will basically add two lists together. Index will give you an index. Return, it will return an index value of any given value, right? Any given element. Insert will insert an element at any given index value. Pop will basically remove an element based on its index value. Remove will remove an element based on the element itself, not the index value. Reverse will basically reverse the list, and sort will sort a list, right? So we have seen all the functions of list. We know that how lists are different than tuples. Tuples just had two functions, count and index, if I'm not mistaken, right? So this was all about lists. In our next video, we will learn about dictionaries, and after that, basically, I'll go through a little bit about how do we properly initialize those variables. We have seen integers, floats, strings, tuples, lists, and in our next video, we'll cover dictionaries as well. But it's good to know how do we actually start writing a program, and how do we basically define, initialize all those variables. What is the right way to initialize all those variables, right? We'll also go through that a little bit. It's a best practice. I highly recommend you to check that video out. That probably would be video number 6. That'll give you how do we basically initialize, what are different ways we could initialize different data types, and what is the best way of doing that, right? So I hope the video has been valuable investment in your time, and you've liked it. If you've liked it, please press the like button and subscribe to my channel. Thank you so much.